All right, yesterday we started talking about 1.7, and you learned about functions and domain and range, how to tell if something was a function, and how to represent a function in a table. So today we're going to talk about a few more things. And the first thing we're talking about are mapping diagrams. So on your screen is a mapping diagram. You see a box with input and output. You can also think of those boxes as domain and range. They mean the same thing. Notice that an output may be paired with more than one input, but no input is paired with more than one output. So if we were representing this function with a table, it would look something like this. We'd have our domain and range in the same spots, which we're also calling input and output. So let's look at our input numbers. We have 1, 2, 3, and 4. Now we can look at our output values. So I can see based on this diagram that if the input is 1, the output will be 0. If the input is 2, the output will be 1. If the input is 3, the output will be 2. And if the input is 4, the output will also be 2. Let's take a look at some things you might be asked to do with mapping diagrams. One thing you'll be asked to do is to identify the domain and range of a function. Well, I know that I have inputs here and I have outputs here. So input is domain. So my domain is 2, 4, 8, and 9. The output is the range, and our values are 1, 2, 4, and 11. You may be asked to create a mapping diagram, and all you do is I'm going to make 2 boxes. I'm going to have my inputs and my outputs. And I'm just going to list the values I see in the table. So we have 1, 2, 3, and 4 for input values. We have 4, 7, 10, and 13 for output values. Now I'm just going to draw arrows going from the correct input to the correct output. So the input of 4 gives the input of 1 gives an output of 4. 2 gets us 7, 3 gets us 10, 4 gets us 13. Let's change up those output values though and see what this looks like. So we're going to start with the same first step. I'm making a box for inputs and outputs. I'm going to start with my inputs. I have 1, 2, 3, and 4. So for outputs, I have 5. And since I have 2 5s, I only have to write that once under outputs. I have a 6 and I have a 12. So now we just have to draw our arrows to connect the inputs to the outputs. So the input of 1 gives me an output of 5. The input of 2 gives me an output of 12. The input of 3 gives me an output of 6. And the input of 4 gives me an output of 5. So this mapping diagram looks a little bit different than the first one. It's okay to have arrows cross. It's okay to have less outputs than you do inputs. The only thing that wouldn't be okay is if we had one input going to multiple outputs. And that brings us to our last example for mapping diagrams. You'll be asked to tell whether or not a pairing is a function. And so I'm looking here, and I see the input of 0 is giving two different outputs. And if you ever see one input mapped to two different outputs, you know that that is not a function. Because each input needs a unique output. If it were the other way around and we had different inputs giving the same output, that would be okay. So if we had something like this would be a function. So make sure that when you're looking at these mapping diagrams, each input is only going to one output. You cannot have an input going to multiple outputs. All right, the next thing that we're going to talk about today is writing a rule for a function. And what that means is we are writing down how do we get from the input value to the output value? What is happening to that input to give us that output? And the way that we do that is we look for a pattern. So if we're looking in the top row of this table, we have our input values. The bottom row has the output values. So if I look here first, I'm going to ask myself, what are the ways that I can get from 0 to 2? And then I'm going to ask myself, what are the ways I can get from 1 to 3, from 4 to 6, and so on. So the thing about writing a rule for a function is it has to work for each input value to get to the matching output value. So for this one, if I look at the input, to get from 0 to 2, that's plus 2. To get from 1 to 3, that's plus 2. 4 to 6, that's plus 2. 6 to 8, that's plus 2. 10 to 12, that's plus 2. So if I were to say this out loud, I would say, okay, I'm taking my input value, I'm adding 2, and that's what gets me my output value. So to write this as a function, we need to use some variables, and we're going to use x and y. So the input value is x, the output value is y. So if I'm writing this as a rule, I can say the output, or the y value, is going to be equal to the input, or the x value, plus 2. And that's really all there is to that. You're looking for patterns. So this table is showing us time in hours compared to pay in dollars. We're going to do the same thing. So what are some ways I can get from 1 to 8? What are some ways that I can get from 2 to 16? What are some ways I can get from 3 to 4, from 3 to 24? And what are some ways that I can get from 4 to 32? So to get from 1 to 8, I could either add 7 or I could multiply by 8. So if I go to check my other input values, 2 plus 7 is 9. I'm looking for 16, so that won't work. 2 times 8 is 16, so that would work. 3 times 8 is 24, that would work. 4 times 8 is 32. So just like for our last function rule, we have x as our input, y as our output. So I can say y, the output, is the same as the input, or x, multiplied by 8. You can also write function rules for real-life scenarios. So this one about concert tickets is saying you are buying concert tickets that cost $15 each. You can buy up to 6 tickets. Write the amount in dollars you spend as a function of the number of tickets you buy. Identify the independent and dependent variables, then identify the domain and the range of the function. So we're just going to break down what we know here. You're buying concert tickets. Each one costs $15. You can buy up to 6 tickets. So if we want to know how much we'd spend for up to 6 amount of tickets, we could say something like this. The amount you spend in dollars is equal to the cost per ticket multiplied by the number of tickets purchased. And that looks like A equals 15N. You don't have to use A here. You can do whatever you want. You should pick a letter that just keeps whatever the variable stands for in your mind so you don't get confused. So the next part of this question is asking us to identify the independent and dependent variables. So the dependent variable, the value of that changes depending on what your independent variable is. So the value that we control, that we are going to change, is the number of tickets that we can buy, which is N. So N is our independent variable. The amount you spend depends on the number of tickets you buy, so that's going to be our dependent variable. So the last thing we're being asked to do here is to identify the domain and the range of the function. Well, we know our domain is going to be the numbers 0 through 6 because that is the amount of tickets that we can buy. To find the range, we can just fill out a function table. So if we buy 0 tickets, you pay $0. If you buy 1 ticket, you pay $15. If you buy 2 tickets, you pay $30. 3 would be $45, and so on. So now that I have this function table filled out, I could write my domain as 0, 1, 2, 3, 4, 5, 6. And my range would be 0, 15, 30, 45, 60, 75, and 90.